Recording in progress.
Covalent bond. Previously, we have completed our discussion on the ionic bond, and you know how ionic bonds are formed? By the combination of ions, right? The positive ions and negative ions. What are positive ions
Negative
known as?
ions. Uh, Ionides.
Hmm. Positive. Cations. They
Oh,
are known as
yeah,
cations.
cations, cations.
Yeah. And the
Positive
negative
cations and
ions,
negative charges, anions.
anions. And how anions are formed? And how cations are formed?
Like when
Mhm.
what's it called? They form when like an atom gains like an electron.
Yeah. Then anions are formed. And what about cations?
Yes. Cations are formed when like electrons like when an atoms loses an one or more electron.
Yeah, then cation is formed. And usually, which species prefers to lose electron? Which element? We have three types of elements in the periodic table: the metals, non-metals, and metalloids. Okay, metalloids are those which
Yes.
have properties of metals and as well as
Metal
non-metals.
and non-metals.
Yeah,
Yeah.
metals tend to lose electrons because they have a pool of electron. While on the other hand, we have non-metals, and those non-metals tend to accept electron, right?
Yes.
Okay. Why? And yes, we have had a discussion on this. That why do atoms make bond? Why do atoms make bond? We have already discussed it.
Oh,
Mhm. Like
to like
they are present in group one, group two, group three, four. Then why is it needed for this group one to make bond with group seven, or group one element to make bond with group number six? Why is it so? Why they do so?
because maybe because to fill the
Hmm.
what's it called fill the valence electron shell.
Yes, because their valence shell have some vacancy in them. Like if we talk about the non-metals, their valence shell is vacant. Okay, vacant means there is some vacancy available. Firstly, you must know what is meant by this. Why we are discussing vacancy. First thing is that we know the stability rule. Okay, how we say that
Hmm.
one species is stable? We say on two bases. We say whether a species will, in its valence shell, there may be two electrons, then it means it is following the duplet rule. Okay, or whether
Yeah.
the second condition may be that a species may have eight electrons. Okay, then it means
Mm.
the species is following the octet rule. Okay, so these are the two things. These are the two rules which every element has to follow. Okay, for stability purpose. Otherwise, they are arranged in this periodic table. They are present in individual form. They are represented in the periodic table, but in individual form they are not present, except that of noble gases. Okay, and we know that the reason why noble
Mm.
gases don't make bond.
Because like they have their valence electron shell is full.
Yeah, their valence electron, and they have eight electrons in their valence shell, only except that of first. First one is helium. Okay, first noble gas is helium. It has two electrons in the valence shell. Okay, helium follows the duplet rule. All other, all other follow octet rule. Okay, all other elements of the group number eight follow the octet rule. Okay, so they don't need to make bond. Else, all other groups present in the periodic table, they have to make bonds. Okay, they have to make bonds for stability purpose. Okay, for example, if we talk about the group number one and group number two, how many electrons are there in the group one and group number two?
Group 1 and 2.
Hmm. How many electrons are there
Group
in the
one
valence shell
has
of the group number one?
group number one. They have one valence electron shell.
Yeah, group one, in its valence shell there is one electron. What about the group number two?
Two valence electron shell.
Two valence electrons. Okay, so it means, and they are metals. Okay, so what they will do? They will lose electrons, and once they will lose electron, they will vacant this shell, and their last shell will be following the octet rule, right? Just like I gave you the example of
Yes.
the magnesium. Okay, magnesium is, it is 12. Okay, so it means it is
Hmm.
2, 8, and 2, right? It will lose these two.
Yes.
It will lose these two. Then this will become its valence shell, right? That means it
Hmm.
has followed
Yeah.
the octet rule, right?
Yes.
So this all we have discussed in the ionic compounds. Okay, how ionic compounds are formed? One species loses electron and other species gains it. Okay. Now we are going to discuss some another type of bonding. Okay, this is based on the sharing. Okay, like for example, you have $5. Okay, and your friend has $3. What you both can do? You don't want to lose 5 electrons. Okay, I told you
Yeah.
that this is not possible. So what you can do, you both can share. Okay, then
Okay.
the total will be 8. So this is another type of
Yes.
bonding in which the two elements combine by sharing. Okay, they share their electrons with each other, right? So this is known as
Yes.
covalent bonding. In covalent bonding, we will see that atoms uh, they have mentioned, but that is not only the way. This one, which we have discussed in the ionic bonding. Ionic bonding, firstly, the sodium and chloride. The other way is that atoms can also gain full outer shell by sharing electrons. Okay, by sharing electron with each other. This is another scenario.
Mm-hmm.
Okay, and if this is happening, then we will say this is a covalent bond. Okay, we okay. One more thing, we cannot say sodium chloride. It is having a covalent bond. Why we cannot say this?
Yeah.
Because we have discussed that sodium loses electron, right?
Yes.
And chlorine gains electron. Okay, and it becomes chloride.
Mm-hmm.
So it is losing and it is gaining. That's why this is ionic compound. You cannot say that this is a covalent bond. Only those compounds which are formed by the sharing of the electrons, that will be known as covalent bonds, right? I hope you are clear with
Yes.
this.
Yeah.
Okay. So, yes, if I ask you in the test why sodium chloride is not a covalent bond, then you have to justify me that why is it so? Because sodium is losing electron and chlorine is gaining electron. It means they are forming
Easy clear for
ions.
you.
Yeah, they are forming ions, and there is ionic bonding in them. Okay, they are not sharing.
Mm-hmm.
They are losing. One species is losing, another species is gaining. But if you have two species, and those two species share their electrons, valence shell electrons, okay, not the inner electrons. It is not possible to share your inner electrons. You just share the
Yes.
valence electrons. This one,
Mm-hmm.
okay, to gain the full outer shell. So this one would be covalent bond. Clear?
Yes.
Okay, now they have mentioned this one. This is very important point that atoms of known metals do not give up electron to obtain a full shell. Okay, you know this that chlorine is a non-metal, fluorine, bromine. They don't lose their electrons, right? We have discussed that fluorine, bromine, or any other non-metal, just like the group number 4. Let's say the carbon, group number 4. Carbon is in the group number 4. Carbon,
Yeah.
although it has 4 electrons, it can lose, it should lose 4 electrons, but it is not the case. Carbon
Mm-hmm.
do not lose its electron. Why? Because this is non-metal. Okay, non-metals don't lose
Yeah.
electrons. This is an important
Yes.
thing that non-metals don't lose
Don't lose
electrons
electrons.
to obtain a full shell because they would have to lose so many. Yeah, this is they have mentioned reason why they don't do so because if they are going to lose, they have to lose many. Just like chlorine. In the chlorine valence shell, chlorine is 17. Okay, so it is 2, 8, and 7. If it wants to lose, how many electrons should it lose? How many electrons should it lose?
If it has two electrons.
No, it has in the valence shell it has 7 electrons. Okay, so
Yes. Yes.
it has to lose 7 electrons. Okay, if it's going to lose, that's why chlorine
Yeah.
does not lose because it has to
Mm-hmm.
lose so many. This is what they are saying
Yes.
that non-metals usually don't lose electrons because if if this will happen, what will happen? They will have to lose so many. Okay,
Yes.
metals can lose because metals just have to lose 1 electron or either they have to lose 2 electrons, right? The group number 1
Yeah.
they lose 1 electron, they lose 2 electrons, or maximum the group number 3 they lose 3 electrons. Okay, 3 electrons, just like the aluminum. I gave you the example of aluminum yesterday. Okay, that was from aluminum belongs to the group number 3. So they can lose electrons,
Yes.
but when we talk about the non-metals, it is not easy for non-metals to lose electrons, right?
Yeah.
Clear? Are you clear with this? Why non-metals lose
Yes.
electrons? Because if they have to lose, then they will lose so many electrons, and this is not the case. No species want to lose so many electrons. Okay.
Mm-hmm.
Okay. And to lose, if it want to lose, it has to use so much energy. Okay, if any species, if any non-metal, just like the chlorine, it has to lose 7 electrons, then obviously you need so much energy to lose 7 electrons, right?
Yes.
So that's why they don't prefer to lose. What they prefer? They prefer sharing. Okay, non-metals. What is the
Yeah.
preference for non-metals? They prefer to share electrons. Clear?
Mm-hmm.
And also one more
Yeah.
thing, you will see covalent bonding between non-metals and non-metals. Okay, you will not see
Mm-hmm.
covalent bonding between ionic compounds and between metals and non-metals. Okay, this is
Yeah.
not the case. If they ask you in the MCQs that you have one metal, okay, and one non-metal, which type of bonding will be this? This will be ionic bonding. Okay, just
Mm-hmm.
like we have done. This is ionic bonding. Why? Because just for this you can take, you must have an example in your mind, sodium and chlorine, okay? Sodium chloride. Sodium is a metal, will lose electron, chlorine will gain electron. So this will be sodium chloride. But if they say that you have non-metal, one species non-metal and other one is also non-metal, okay? In this case, what type of bonding this will be? This will be covalent bonding, okay? Are you
Mm-hmm.
clear?
Yeah.
And why for covalent bonding we need non-metal? Because we know that covalent bonding happens through the sharing of the electron. Okay, covalent bonding happens through sharing, right? Okay, let me explain you this
The yes.
over here. As I told you, how covalent bonds are formed? They are formed by the sharing of the electrons. Okay,
By sharing.
and which species has a tendency to share electron? Metals or non-metals? Which species wants to share?
Uh, non-metals.
Yeah, non-metals don't lose electrons either. They tend to share electrons. Okay.
Mm-hmm.
So which two species will make covalent bond? Non-metal and non-metal. Okay.
Mm-hmm. Yeah.
These two species will make the covalent bond. Clear? Are you clear
Yes.
with this? You have two and you know
Yeah.
that in the periodic table where non-metals are located, they are located on this side. Okay, from this one. Okay, this side is of non-metals. Right? Clear?
Yes. Yes.
Okay.
Yeah.
And one more thing, if we are talking about the non-metals, so it means that same elements, if same elements want to combine, this can also be, this comes into your mind that, okay, if we have one carbon and one carbon has 4 electrons, okay, so why carbon cannot make it bond with itself? This can also be a possibility, right? Like for group 4 elements, like the carbon,
Yes.
let's say we have carbon, okay, and another carbon. They both have 4 electrons in their valence shell.
Mm-hmm.
Can they make bonding? Can they do bonding?
Uh,
Covalent bonding.
no.
Why?
No.
Why?
Because one is a metal and one is not non-metal.
No, they both are carbon. I have mentioned carbon.
Oh, yes, they can.
Why?
Maybe because like
Hmm.
both of them, what's it called? Uh,
Think about it. See the screen. See the screen. What I have mentioned in the screen. All this sharing of electron, non-metals, and non-metal. What is
yeah,
this?
because it's a non-metal. Yeah, it's a
Yeah.
non carbon is a carbon
Carbon is
is
a
a non-metal.
non-metal. Yeah. And it belongs to group number 4. It belongs
Yeah.
to group number 4. So carbon can make bond
Yes.
with its own another atom of carbon. Okay, this is a possibility. This can happen. Okay, that's
Yeah.
why we have carbon-carbon bonding. Okay, and we discussed this
Mm-hmm.
carbon-carbon bonding in organic chemistry. We will have this in, I think, part 3 of the IGCSE, organic chemistry. It is a very vast branch of chemistry. Have you seen organic products, the beauty products? They are organic in
Yes,
nature.
yes.
Those are made by this type of bonding, carbon-carbon bonding. Okay,
Mm-hmm.
carbon-carbon bonding can be single. It can also be like this. It can also have three bonds, but not beyond three. Okay, so this type of
Yeah.
bonding is known as covalent bond. Okay, this is covalent bonding because okay. Now one more point we have discussed, that we need non-metal. Okay, and same type of atoms can combine. Okay, same type of atoms can combine to make covalent bond, right?
Yes.
But non-metals, you cannot say that you have a sodium and sodium, so they will make covalent bond. This is not the case. Why? Because sodium is a metal, so this cannot happen. Okay, you need non-metals.
Mm-hmm.
Same type of non-metal atoms can combine to form covalent bond. Clear?
Yeah.
For example, you have hydrogen, right? We have hydrogen. What is the hydrogen belongs to group number one? Okay. So what is its valency?
For what?
Hydrogen.
Hydrogen?
Hydrogen. Hmm.
Hydrogen has what's it called?
Hmm. It belongs to group number
Uh,
one.
yeah, one. Yeah, so one
Okay.
electron.
Yeah. In its
One
valence there is
proton.
one electron. Okay. I have mentioned
Yeah.
like this. Okay. Now I want its bonding with its another atom of the hydrogen. Okay. Is this possible?
Yes,
Why?
because both are metals.
Yeah, both are non-metals. So I need another. I will make a circle like this. Okay. Hydrogen, and over here
Mm-hmm.
cross. Okay. Cross for this hydrogen. Are you getting this? How covalent bonding occurs?
Yes.
Basically, how we represent this? We represent it like this, and like this. And in the center, you will make a dot and a cross. Okay. Dot for this hydrogen and cross for this hydrogen. Clear?
Mm-hmm.
So this is known as, yeah. You see, two hydrogen atom approach. One they have represented by the cross and the other one by dot. And this is a sharing. Okay, a shared pair of
Yeah.
electrons. Okay, so it means, what does it mean? It means whenever you see this bond, it means it has two electrons, one of this hydrogen and one of this hydrogen. Clear? So in one bond,
Yes.
this question can arise. In one bond, how many electrons are there? In one bond, how many electrons are there? Two electrons, right? This is one bond.
Yes.
This is a bond, and this is known as covalent bond. Okay, this is known as what? Covalent bond, right? And in this bond, how many electrons are there? Two. Clear? One for this
Mm-hmm.
hydrogen and one
Yeah.
for this. If you have any confusion, still if you have any confusion in this, we can do this again. In covalent bonding, non-metals, you need non-metals. Same type of atoms can make bond. They can combine together. And how they will combine? They will share electrons, right? There will be a sharing of the electrons.
Yes.
Clear?
Yes.
Okay. Then we have, yeah, we can take another example of the, yeah, just like they have mentioned the chlorine, okay? Chlorine, belongs to group number 7, right? It belongs to group number 7. So you will make chlorine
Yes.
like this. You just need to make the last shell, okay? Just last shell of the chlorine. And you know how many electrons are there in
Yeah.
the chlorine last shell? 2, 8, and 7, right? It is 17.
Yes.
So how many electrons are there in the valence shell of chlorine?
7.
7. So for this I have mentioned 1, 2 in the form of pairing. Okay, always draw in the form of pairing. 1, 2, 3, 4, 5, 6, and 7th on this side. Okay, because on this in front of it I have to make a new bond, another bond. Okay, again I have taken another chlorine of same size. Okay, take same sizes because chlorine has same size. 1, 2,
Mm-hmm.
3, 4, 5, 6, 7. Okay, now they both will approach each other, right? And there will be a sharing.
Yeah.
Okay, you have to exactly follow this diagram. Okay, if I ask you to make the
Mm-hmm.
image, the diagram of the covalent bond. Okay, this one. So what will be in the, okay? How we can fill this? Wait a minute. This one. Now you see in the center, this will be there. Okay, like this one, right? This one, and this one will be in the center.
Yes.
All other will be on this position. Process, cross, and this. Okay. Now you see their valence shell is filled. 1, 2, 3, 4, 5, 6, 7, 8. If you see this chlorine, 1, 2, 3, 4, 5, 6, 7, 8. Right? Clear? So this
Yeah.
is how covalent bonding occurs. This was, and if I want, you have to also mention this like in this form, normal form, right? This one. Clear?
Yes.
It means all other are
Yeah.
this line is showing that this bonding. Okay, this bonding is shown by this line. Okay,
Mm-hmm.
it means this is a bond. This is a covalent bond. Clear? Are you
Yeah.
clear with this? Now I can show you some other examples like just like the oxygen. Okay, now you have to tell me why there is double bond in oxygen. Okay, see this and explain me. Firstly, whenever we are doing bonding, the first thing is you must know the electronic configuration. Okay, you must know what
Mm-hmm.
is the electronic configuration, how many electrons are there in the valence shell, because we have to draw valence shell electrons, right? We have
Yes.
nothing to do with the electrons which are present inside in the first shell or in the second shell. We just have concern with the valence shell electrons. How we will know the valence
Mm-hmm.
shell electron? Which definitely we will know by the electronic configuration. And you know what is the electronic configuration of oxygen?
Uh,
Mm-hmm.
of oxygen, it's 8.
Eight is total. Okay, so valence shell
Yeah.
will be 2 into 6, right? How
Yes.
how many are in the valence shell?
How many? Two. It will be
Mhm.
6.
6 in the valence shell. Okay, this
Yes.
they have mentioned these 6. Okay, how they have mentioned now? You know, obviously you have total 6. Okay, you have total 6. So you can draw like this. Okay, like this. But this is not possible because we have to,
Yeah.
in the valence shell what is needed? 8 electrons are needed, right? 8
Yeah.
electrons are needed. So how you will? Wait a minute. Hmm, yeah. So you will represent electrons like this. Okay, two this pair, two in this pair, and these are separated. Okay, these are in the separate
Mm-hmm.
form. Okay. Similarly, you have another oxygen. You have mentioned by the crosses. Okay, so this is one bond and this is second bond. Are you getting this? What they have done? Basically,
Yes. Yeah.
you have one oxygen. Okay, and this is sorry, this is 8, 2 and 6. Okay, another oxygen. This is also same, 2 and 6. Okay, in the valence shell there are 6 electrons. Both have 6 electrons in the valence shell. How you will represent?
Yeah.
You will represent it by like this. Firstly, 2 in the pair, this pair and this pair.
Yeah.
4 are completed, right? You have mentioned 4 electrons. How many are left?
So like
There are 6, right? In the valence shell there are 6. So you
Yeah,
have to
yeah.
represent the 6. I have represented 4.
Yes.
How many are left?
2 more.
2 more. So one I am representing here and the other one here. Clear? Are you clear with this?
Yes.
This is the steps I am telling you how you will make the diagram. Okay, another oxygen. The size is not same. We have to take the same size. Okay. Now I am representing with crosses. Okay, 1, 2, 3, 4, and this one 5 and this one 6. Okay, you see these should be in the pairing form. Okay, this one should make a pair. This one should make a pair. This one should make a pair, and this one should make a pair. Right?
Yes.
So what they will do? They will make bonding with each other. Right? Like this. Clear?
Yeah.
So when they will make a bond like this, when they will make a bond like this, what will happen? You will get a new diagram that will be, yeah, over here you will see, you will show this intersection area. Have you done intersection in mathematics? Union intersection.
Yes.
What is
Just give me
intersection?
1 minute. Just give me.
Okay.
I'll be back.
How this
Recording
bonding
in
is happening?
progress.
Because these are present in free form. Okay, they are not, they don't have make the pairing, so they will combine with each other. Okay, and this is how you will
Mm-hmm.
show the bonding. Okay, this is how you will show the bonding. Okay,
Bonding.
you will mention it over here. You will make an intersection area. Okay, intersection means a common area. And now in this intersection area, how many you will show? You will show this dot, then cross, then this dot, then this cross. Okay, there are 4. I hope you are clear with this.
Yes.
And all other
Yeah.
are on the same position, like this, and like this. Clear? Now this is the
Yeah.
covalent bonding, right?